Hello, this is Mr. Stein, and in this video, we're going to go through examples number 3 and 4 for section 6.4, slope-intercept form of the equation of a linear function. After you're done 6.4, you should be able to graph a linear function of the form y equals mx plus b. Determine the equation in y equals mx plus b form given a graph. In math, if you learn how to do something one way, you have to learn how to go the other way. Convert other forms of equations into y equals mx plus b. Relate the equation of a graph to a real-life situation. All right, let's head on over to examples 3 and 4. Example 3, write an equation to describe this function. Then we're going to verify the equation. All right, so there's two things that we need to find in this. We need to find the y-intercept. Y-intercept in this graph is right there. It's at 0 on the x, negative 3 on the y. The next thing we need to do is we need to find the slope. So we find 2 points on the graph that intersect corners properly, very nicely, and then we look at the rise, plus 2, and a run of plus 1. So our slope is a rise of plus 2 over a run of plus 1. Now we can write our equation in y equals mx plus b form. Well, our slope is equal to plus 2x, and our b is minus 3. Right, the plus b part here just means that we put in whatever sign it actually has. So our y-intercept has the sign of minus 3, so it has the sign of minus 3 there. Now let's verify this. To verify, what we're going to do is we're going to build a table of values. We're going to put in some values of x and determine our values of y such that we have 2x minus 3. Then we're going to check them on our graph. So we put 0 in for x. Then we're going to do 2 times 0 minus 3, which is 0. We're going to put 1 in for x. Then we do 2 times 1 minus 3, which is, oh, my goodness. You don't put 0 in for x and get that. You put 0 in for x and you get minus 3. You put 1 in, you get minus 1. You put 2 in for x, you get 2 times 2 minus 3, which is equal to plus 1. You put 3 in, you get 2 times 3 minus 3, which is equal to plus 3. Now let's check these points on our graph. Well, this is the point 0 minus 3 right here. That checks out. Now let's check out this point 1 and minus 1. 1 and minus 1. That's 1 and minus 1 right there. Now let's check out the point 2 and plus 1. 2 plus 1. That's the point 2 and plus 1. 3 and plus 3. Point 3 plus 3. Right there. We've verified our equation. The table of values given by our equation matches our graph. Right, so that's how you take a graph and turn it into an equation. Now we're going to look at an example, and we're going to look at this in a real-life situation. To join the local gym, Karim pays a startup fee of $99 plus a monthly given fee of $29. Write an equation for the total cost in dollars for n months of the gym. B, suppose Karim went to the gym for 23 months. What's the total cost? Suppose the total cost is $505. How many months did he use the gym? Could the total cost be exactly $600? Justify your answer. All right, so let's look at letter A. So he has a startup fee of $99. He has to pay that right away. And he has a monthly fee of $29 per month. So that's our rate. Our rate, when we have a rate of change, like $29 per month, that is going to be our slope. So the cost of this equation is going to be equal to $99 to start with, plus $29 for every month that he goes. N stands for number of months. Now we could rearrange this into y equals mx plus b form. It could be like this. cost is equal to $29 for every month that he's there, plus $99 initial cost. Right, so we've got an equation here in y equals mx plus b form. This is our slope. This would be the slope of our line, $29 every month. And this would be our y-intercept. At 0 months, it's $99. Letter B. Suppose Kareem went to the gym for 23 months. What is the total cost? So I'm going to rewrite this in function form. So the cost for a given number of months is equal to $99 plus 29n. Now he's going for 23 months, so the cost for 23 months is equal to $99 plus 29 times 23. So that is going to be, I need a calculator for this. I can't really do this one without a calculator. So I'm going to do my 29 times 23 first. 29 times 23 is equal to 667 plus 99, $766. All right, so this total cost would be $766 for 23 months. Suppose the total cost was $505. So in this one, our total cost is equal to $505. So we want to figure out how many months it took. Now we could graph this and use the graph to figure it out, but it's just much easier to do on an equation. So we put our 505 in for our cost is equal to 99 plus 29 times the number of months that he goes. So I subtract 99 from both sides. So 505 subtract 99 is equal to 406. It's equal to 29 times the number of months. Divide both sides by 29. And I get 14 months. Okay, our last one. Letter D. Could the total cost be exactly $600? Justify. Well, you only ever pay in whole number months. So let's see if a total cost of $600 will get us a domain value that is a whole number of months. So let's do letter D. We're going to put 600 in for our cost is equal to 99 plus 29n. Subtract 99, subtract 99. 501 is equal to 29n. Divide by 29, divide by 29. We get n is equal to, shouldn't have closed my calculator so quickly. 501 divided by 29, 17.3. So this value is not part of our domain. We can't have fractional months, or can't have decimal months. You pay for one whole month at a time. If we were to write the domain for this function, our domain for this function would be the variable n, all the number of months, such that the number of months have to be an element of the whole numbers. So 0, 1, 2. 17.3 is not an element of the whole numbers. So we can't have a total cost be exactly $600. It doesn't fit in our pattern. All right, I hope this is helpful to you. I hope you can do all the I can statements.